Good morning, good afternoon, good evening, and good night. My name is Shinram Chivo. We're back here with yet another LeetCode video. Exciting, I know. Today we're looking at question 554, which is called brick wall. So it says that there are rectangular bricks. There's a rectangular brick wall in front of you with n rows of bricks. The ith row has some number of bricks, each of the same height. I can't read today, but they can be of different widths. The total width of each row is the same. Draw a vertical line from the top to the bottom and cross the least bricks. If your line goes through the edge of a brick, then the brick is not considered as crossed. You cannot draw a line along just the two vertical lines of the wall, because then you would cross no bricks, obviously. I mean, that would have been the right thing to do. Okay, so they have 1, 2, 2, 1, 3, 1, 2. Okay, I'm gonna draw this out and let's see what they mean. Okay, let's make that black. And so they're saying that I have a brick wall, and the colors will represent the bricks. So in this case, the length is 1 plus 2 plus 2 plus 1, so it's a 6 length brick wall. So I'll just do some dots. So you'll have 1 brick, 2 bricks, 3 bricks, 4 bricks, 5 bricks, 6 bricks. And there are a total of 1, 2, 3, 4, 5, 6 layers of bricks. 6 bricks. Okay, let me draw that out. That's brick 1, layer 2, layer 3, layer 4, 1, 2, 3, 4, 5. 5, sorry. And layer 6. Beautiful. Okay, and each of these have 6 possible bricks, but some of the bricks are longer than others. So they could have a max of 6 bricks, but some rows might have way less. Might have just one long brick across the whole row. Okay, so for this top one, it goes a brick of length 1, then a brick of length 2, then another brick of length 2, then a brick of length 1. And then this guy goes a brick of length 3, then a brick of length 1, then a brick of length 2. Then the next row, we have a brick of length 1, then a brick of length 1, 2, 3. 1, and then 1, 2, 3. Hold on. A brick of length 1, and then a brick of length 1, 2, 3. Yes, there's no dot there, that's why. And then a brick of length 2, and a brick of length 4, then a brick of length 3, a brick of length 1, and a brick of length 2. And then finally, saying brick so many times becomes not a real word, you know? Brick of length 1, then 3, then 1 again. Okay, and so how can I cut through the least number of bricks? So I'd want to go through where there are the most number of endings for the bricks. So that's here, and in this case I'm cutting through 1, 2, 3 bricks. What if I cut through here though? In this case I'd only cut through 2 bricks, no? Yeah, so this would be the best cut if I cut through right here, because then I'm matching up with this line and these lines, so I'm only having to cut through this brick and through this brick in order to complete the line all the way across. Interesting. Okay, so basically what we want to do is we want to find out at which point is there a maximum number of these ends of bricks. So how are these ends of bricks represented in code? So it's basically 1, then 2, then 2, then 1. How is that represented in code? This is 1, then 2, then 2, then 1. Okay, so there's an end right at 1, there's another end at 2, there's another end here. Interesting. So if I know the whole length of the brick, right? What if I break it up into 6 possible places you can have ends of bricks, or maybe not 6. 1, 2, 3, 4 possible, because it said not at the start and not at the end, right? So it's just 1, 2, 3, 5 possible. 1, 2, 3, 4, 5 possible brick splits. Okay, that makes sense. And then for each of these 5 possible, I'd want to find where the most were split, right? So like, what if I had a counter type of dictionary? So if I just found a way to see when each one was split. So this one has a split at basically, like I could see where the splits are for each row. This one has a split at 1, at 2, 3, at 3, at 4, 5, at 5. So it has splits at 1, 3, and 5. And then this one has splits at 1, 2, 3, and at 4, right? And then this one has a split at 1, 2, 3, 4, 1 and 4. Okay, this guy has a split at 2. This guy has a split at 1, 2, 3, and 4. And then this guy is a split at 1, 2, 3, and 4, 1 and 4. Okay, and then based off of these numbers, I see that the one that happens the most times is 4. Okay, so 4 would be where my line should be drawn, but then I still need to figure out which ones are left. And that would basically, okay, because that would just be which ones don't have a 4 basically. I know that there's 6 in total, and if 4 of them have a 4, then it's the other one that doesn't have a 4. Okay, so that's how I think I'm going to do it. I think for each layer of bricks, I'll keep track of basically where the brick splits are. That's the technical term, of course. And then I'll basically keep track of that, and then whichever number has the most brick splits, I'll count how many of those brick splits exist. These terminology terms are just getting crazy. And then I'll subtract that from the total number of rows of bricks. That's my current thought process. Okay, so let's translate this to code. So what I'm thinking for keeping all of these numbers, is to have a dictionary, which is like a data structure that has like key value pairs. So basically what that means is that the number 4 could have, say, row 1, I would have like the split as maybe the key, and then the values would be maybe a list of all the rows that have splits of that key. By that I mean, let's say a split could possibly be at 1, 2, 3, 4, or 5, because those are the 5 different split positions. So in the dictionary, I could have, this is the key, and then the value would be whichever ones have splits at 1. So this row has a split at 1. So let's call this row 1, row 2, row 3, row 4, row 5, and row 6. So row 6 has a split at 1. So 1 could go with that row, right? And this also has a split of 1, that's row 3. And this also has a split of 1, that's row 6. And then I do the same for all of the different possible values. And that's what I'm currently thinking. This may or may not work. Usually doesn't on the first try, but we will try our best. Okay, so that's my current thought process, and I will try and implement it in code. So first I'll have my dictionary that will keep track of the brick splits. So brickSplitDict, and I'll start off as empty, and then for each row that's going to be in my wall, so I'm going to make this full screen for now. So I'm going to go through each row in my wall, right? So there are a lot of rows, but the wall is representing this wall. So I can go for row in wall. So for each row in the wall, I'm going to want to add where the splits are. So how can I do this? So if I just look at what the rows are, like how they give them to me currently, it just looks something like this. So each row is just like that, like that, like that. So what I want is I want not the rows, but the sum of the splits. So basically, instead of 2, this should be 3, right? Because that's when the split is. And I don't care about this last number. So I care about the sum of these guys. So I want to go in each row now. So for brick in row, and what am I doing here? I'm basically seeing the sum, right? Because this is at 1, and then this is at 1 plus 2, so that's 3, and 1 plus 2 more, so that's 5. So it's kind of like the sum of the bricks, or the brick lengths to that point. So for brick in row, and then at this point, I'd want to sum for each of these guys, right? How can I do that? Okay, so I could just do a regular sum. So let's say rowSum, and I'll start at 0, and for each brick, I will want the row sum to increase by 1, right? So let's see how I can do this efficiently though, because I don't want to calculate too many things. So for each brick in the row sum is going to want to increase by that certain amount, right? What I could do is I could have all row sums, okay? I'm going to start this in a way that makes logical sense, and then I'll probably move it to like a list comprehension or something, just to make it run a slight bit more efficiently. So for each brick in row, I'm going to want to add to that row sum, right? So row sum plus equals, and then the brick is really the brick length. So maybe I'll rename that to brick length to make it less ambiguous. So row sum plus equals brick length. And then I'd want to add that sum to the current dictionary of all row sums. So then I'd want to add that all row sums. And what I should actually do is have, this is getting a little bit complicated, but have a list for that specific row. So I'll have, instead of row sum, I have row sum, but then I also have a list where I can add all of the specific bricks to. So row sum will be something different. I'll have bricks lengthSum, so I'll just call it lengthSum, which is keeping track of the length of the bricks in my current row. And then the row sum will be for the entire row. You'll see what I mean pretty soon. So I will actually add the brick length to the lengthSum, and then each time I'll add that to the row sum. So row sum plus equals, or it's really a list, so I can do .append, and I'll append the current lengthSum. And the lengthSum should be a number, and each time that number is going to increase. So the number is going to start off at 0, and then it's going to become 1, and then 3, and then 5. And I'm adding each of those to my row sum list. And at the end of each row, I'm going to want to add my row sum to all row sums. So allRowSums.append, and I'll append the row sum. And then I want to make the row sum empty again so that it can do the same thing for the next row. So I will make it an empty list. So I'm now adding each brick length to the current sum, adding that to the row sum, and then at the end, adding that row sum to all rows, and then setting that row sum to 0. Let's see what that looks like now, and what errors I may or may not get. And let's print that out so we can see what the row sum actually looks like. I'm currently getting nothing. Oh, I'm setting the row sum to 0. I should be printing out all row sums. There we go. Okay, so let's see if this looks like what we expect. So 1, 3, 5, we don't need the 6, but that's good. And then 9, okay, because I'm not setting the sum to 0. So the length sum should also be set to 0 for each different row, so that it starts from 0 each time. And what we can actually do is just define these right here. That way they get set to 0 anyways, and then take out this definition over here. That should do the same thing. And really we don't need this last one, so we'll actually only go to row minus 1. Not quite. In range length of the row minus 1. Like that. Not quite. Because now, since we're not adding the actual brick length, we want to add the row's brick length. And that should be good. Okay, so now we have 1, 3, 5, 3, 4, 1, 4, 2, 3, 4, 1, 4, 5. 1, 4, 5, is that right? So for this last row, it's 1, 3, 1, 1. 1, 3, 1, 3, 1, 1. Let me think. 1, 1, 2, 3. So shouldn't it just be 1, 4? Interesting. Is it adding one extra length sum? Oh, I think this should be here, actually. Let me just see. One, 4, 5. Not quite. Should it be 1, 4, 5? Should it be? Should it be? Because I have 1, 3, 1, 1. And I had 3, 1, 2. And I had 2, 4. Each time it's 1 less. I feel like I drew something out wrong. Because this one has 3 and it's 4. So it probably should be 1, 4, 5. 1, 3, 1, 1. 1, then 1, 2. There should be 5 dots. So 1, 2, 3, 4, 5. Yes, I'm kind of dumb. There should be another line right here, and that should be 1, 4, 5. Perfect. So even though my brain isn't working, the code is. That's great news. Okay, so now we have all of those, all of these guys. So that's a technical term also, these guys. So what we wanted to do is we wanted to add these numbers to a dictionary, right? So each of these guys should be inside this brickSplitDict. And that way we can keep track of the frequency of each of these numbers. So in brickSplitDict, each time we're going to want to add the lengthSum, correct? Yes, correct. Hold on, is this right? It should be right now, I think, because it should have 1, 3, 5. No, it is all empty. What did I do this time? Oh, yeah, because I'm setting it twice. Silly goose. I am a silly, silly goose. There we go. That should be working. Not quite. This should be called here. Up here. I love copying empty lines. That makes perfect sense. And then that should be there. Now this should work perfectly well. He says for the 18,000th time. Yes, okay. Okay, so now we have all of the different sums and we want to add these all to a dictionary, right? So this brickSplitDict is going to take in each of these separate sums. So it's going to add each number, and basically if the number, it wants to keep track of the count. So if it's the first time it's being added to the brickSplitDict, you got to say that 10 times fast, then you're gonna want to set the count to 1 because that's the first time it's appeared. Otherwise, you'll just increment the count by 1. So if, and then what we're adding is the current lengthSum. So the lengthSum, not in the brickSplitDict, we're going to want to set this guy's lengthSum to equal 1. Otherwise, we're going to want to increment its lengthSum by 1. So we're going to want to add 1 to that current sum. And then we'll print out what that dictionary looks like and hope it looks like what we expect. Let's see. Okay, so it says 1 happens 3 times, does it? 1, 2, 3, yes. It says 3 happens 3 times, does it? 1, 2, 3, yes. 4, what? Yeah, 5, I can't read. 5 happens twice, 1, 2. 4 happens 4 times, 1, 2, 3, 4. And 2 happens once. Perfecto mundo. Okay, sicko mode even. So now we want what happens the most times. So 4 happens the most times, right? And 4 happens a total of 4 times. So we need to find which one happens the most times, how many times it happens, and then subtract the total number of rows from how many times it happened. So first we want to find what happened the most times. So we can just do max of the list of the brickSplitDict dot keys, I think. No, dot values. And first we'll print this out just so you guys can see what I'm doing. Print, that's more like it. And so with the dot values, oh, there we go. Give it a second and try again. Okay. What this should do, perfect, is it prints the values. So it prints the counts basically right now. So something happened 3 times, something happened 4. What matters is something happened 4 times. So we want this maximum number. Okay. And we want the maximum number. We can just do this a different way, actually. Let me do this a way that makes sense. Oh, hilarious. Okay, so we'll go through the dictionary. So for brick row in the dictionary, we're going to want to find the maximum. So max is equal to, nope, max, what is this actually? So that's the max splits at that point. So max splits is equal to 0 currently. And we're going to want to go through the dictionary and find whichever one has the max splits. So max splits, and maybe I'll set it to 2 things so I can keep track of both the key and the value. So max splits will be the max of the current max splits and whatever new item we're finding inside of the brickDict. And we'll want to set both items off maxDict. So how can we do that? No, I don't think we can do it like that. Actually, let's do it this way. So we're going to want to find whichever item has the max values, right? So let's do for key value in the brickSplitDict. And for now, let's just print out the key and the value. If I could spell, the world would be a wonderful place. Okay, so we have 1 3 3 3 5 2 4 4. Perfect. Now what we want is the max item. So we can do it like this. So we'll have 2 variables. So one for the max key, and that will start at 0, and one for the max value that will also start at 0. And so max value is going to be the max of itself, so the current max value, and whatever is the largest key. So that would be, the largest value. And the max key would basically take from the max value. So it would equal the key of the max value. So max key equals if max value changes, basically. So if max value how can we detect change? We could have the old max value and the new max value. So what we could do is we could have max value, it already knows. So if max value, and we'll do this check before actually. So if max value does not equal the same as what this new max value would be, then I'm going to change the max key to equal this new key. Equals key. And at the very end, we'll print the key and the value. Oh, no, we can't do that because that's not in the... It still worked. Odd. Okay. Let's print the max key and the max value. And see what that gives us. 2, 0. I don't think that's right. Oh, I'm not even changing the max value. That would do it. Each time, we still want to change the max value. And I'm doing a lot of unnecessary calculations here, and this could all be simplified a lot, but I just want it to make sense first before any further simplification occurs. So perfect, it's giving us 4, 4, which is great. Now what we want to do is we want to do 6 minus this number. So we will return the length of the wall minus the max value. And that should work. Okay, now we'll see if that works for the other test cases. It does for those two. We'll submit. It might be too slow right now, but it worked. Okay, it's not the fastest, obviously, but all that matters is, you know, we worked through the thought process, we translated it into code, and it actually works, which is pretty sick. I think that's all I'm going to do. If you want, I can put this source code in the description. You can play with it, get it to run a lot faster. And thank you so much for watching. I hope you have a great day. Peace, peace.